All right, let's get right into it. Today, we're doing a deep dive on a tool that really separates the pros from the amateurs when it comes to managing a process. We're talking about the XBAR S control chart. And we're not just going to cover what it is, we're going to break down how you can use it as a serious strategic tool to drive excellence.
Look, this is the question every single operations leader has to be able to answer. Why? Because one good day, or even a whole good week, it doesn't mean a thing if you can't predict what's going to happen tomorrow. The gap between a stable, predictable process and one that just gets lucky now and then, that's the gap between having a profitable operation and just constantly putting out fires. And really, the only way to know for sure is to listen to what your data is telling you, not what you hope it's telling you.
You know, in today's world, just relying on your gut feeling, that's a huge liability. The goal is never to guess. The goal is to know. And to do that, you need a precision tool, something that can cut right through all the noise in your process and give you a clean, clear signal.
And that, right there, is where the XBAR S chart comes into play. Honestly, the best way to think about it is that your process has two different voices. The first voice, it talks about the average performance. Are you hitting the target? And the second voice, it talks about consistency. Is your process predictable? The XBAR S chart is built to listen to both of those voices at the same time, giving you the complete story.
So what we're really looking at are two charts that work together as a team. You've got the XBAR chart, which is tracking the average, the mean of your samples over time. It's telling you if you're staying centered on your target. Then you have the S chart, and the S here is for standard deviation. This one's tracking the spread or the variation inside those samples. This tells you how consistent things are. You absolutely have to have both to see the full picture.
Now, before we go any further, let's just quickly get the language straight. You're going to see these symbols, but trust me, they're super simple. N is just your sample size, how many things you check at once. AM is how many samples or subgroups you've taken. XBAR, that's just the average of one of those subgroups. And S is its standard deviation. That's it. Don't let the symbols throw you off. It's just a little bit of shorthand.
Okay, so we've got the foundation. Now, here's where expertise really comes in. It's not just about knowing how to use a tool, it's knowing exactly when to use it. If you apply the wrong chart to your data, well, you're pretty much guaranteed to make some bad decisions based on bad conclusions. So let's run through the go/no-go checklist for the XBAR S chart.
So here's the checklist. First, your data needs to be continuous. We're talking measurable things like length, weight, time, you get it. Second, it has to be collected in time order so you can actually see trends. Third, the data should follow a generally normal distribution. And fourth, and this one's huge, your sampling method has to be exactly the same every single time. Mess up any of these and your whole analysis is flawed from the get-go. But there's one more rule, and it's the one that specifically tells you to use this chart.
And here it is. This is the big one. Your subgroup size, what we call N, it has to be greater than 10. This is totally non-negotiable. If you're sampling 11 parts, 15 parts, 20 parts at a time, this is your chart. And why? Because with these larger sample sizes, the standard deviation, which is what the S chart measures, it just gives you a way more accurate and reliable picture of your process variation. It's using all the data points, not just the highest and lowest.
So the obvious question is, what if your subgroup size is smaller? Let's say it's between 2 and 10. Well, then you make a change. The right tool for that job is the XBAR R chart, where the R stands for range. The range is way simpler to calculate, and for small samples, it's a good enough substitute for variation. But the second you cross that line to over 10 items, the S chart becomes so much more statistically powerful. Knowing which one to use when, that's a real mark of an expert.
All right, you've picked the right tool for the job. Now for the part that really matters. How do you actually use it to make smart decisions? There is a very strict, very disciplined way to read these charts. It's not about just kind of glancing at them. It's a methodical, three-step process.
And here's exactly how you do it. Step 1, you always look at the S chart first. Always. You're looking for any data points that are outside of those control limits. That's a red flag that your variation is unstable. Step 2, if you see one of those red flags, you stop. I mean it. Do not pass go. You have to investigate what caused that instability before you do anything else. It's only after you've confirmed that your variation is stable, that the S chart is in control, that you've earned the right to move on to step 3 and analyze the XBAR chart.
And you really got to understand why this rule is so rigid. It's not for fun. Those control limits on your XBAR chart, the lines that tell you if your average is stable, they're calculated using the data from the S chart.
So if your S chart is all over the place, it means your measure of variation is unreliable. It's classic garbage in, garbage out. The control limits it spits out for the X-bar chart are basically meaningless, and any decision you make based on them is going to be wrong. This is the mistake so many people make.
So we've covered the what, the when, and the how. Now let's really kick it up a notch. We're going to get into the common traps and the big misunderstandings that really separate someone who's just okay at this from a true expert who can stand behind their analysis.
And that brings us to maybe the single biggest and honestly most dangerous mistake people make with control charts. Sooner or later, someone on your team, maybe even your boss, is going to look at the chart and ask, hey, this is cool, but can we just draw the customer spec limits on there so we can see if we're making good stuff?
The answer is a hard no. Absolutely, positively, never. The second you do that, you've completely invalidated the chart, and you've shown you don't get what it's for. It's like trying to navigate a supertanker using tomorrow's weather forecast instead of a compass. They're both useful, but they tell you completely different things.
Look, it all boils down to this: the voice of the process versus the voice of the customer. Your control limits, those are the voice of your process. They come directly from your data, and they show you the natural variation your process is actually capable of right now. Specification limits, that's the voice of the customer. They're based on what the customer wants, and they have absolutely nothing to do with what your process can do. So think of it this way: control limits tell you what the process is doing. Spec limits tell you what you wish it was doing, and you just can't mix those two things.
Okay, now for a trickier one, but it's just as important. You might run into a situation where your S chart, your variation, is totally out of control. Points are flying all over the place. But the X-bar chart, for the average, it looks perfect, just hugging that center line. So what's going on? Can you just ignore that messy S chart?
No way. In fact, that's one of the most dangerous signals you can possibly see. That nice, stable average, it's a complete illusion. Sure, your process might be hitting its target on average, but the performance from one moment to the next is wildly inconsistent. And remember what we said, that out-of-control S chart makes the control limits on the X-bar chart totally invalid. Your process is basically a ticking time bomb, because that unpredictable variation will eventually knock the average off course. You have to fix the variation problem first.
So let's just be crystal clear about what we're trying to do here. When we use these charts to get a process in control, what we mean is we've made it stable. We've made it predictable. We got rid of all the weird, special causes of variation. That is a massive achievement. But, and this is so important, it does not mean the process is perfect. It doesn't even mean it's making parts that meet the customer's specs. It just means it's consistent.
And that, right there, leads us to the final strategic question. Getting your process stable is a huge win. You've got a predictable system now. But predictability alone isn't enough. The next critical question you have to ask is, okay, is this stable, predictable process of ours actually capable of meeting what our customer needs? And that question, that's the bridge from process control to process capability. And that's where the real business impact happens. Master that, and you've gone from just watching a process to truly managing it for excellence.